Are we ready to go? Okay, good. All right. My name is Jeff Haas. Hi, thank you. We're actually, everything is plugged in and hooked up, and so hopefully everybody can hear everything. So this is a talk about probably the current wave of stuff in computer science. And I will go through my background and everything on this quickly and then get into the meat of it. So my background, I'm not a software engineer by training. I originally started in video games at EA, the Electronic Arts. I was one of the first 200 employees there back in, started in 1987. And I eventually worked as a game producer on the PC, the PlayStation, the Sega Genesis, if anybody remembers any of that stuff. These are pictures of some of the titles that I shipped in things over the time, most of which have been long forgotten. But I worked on a lot of stuff, and you know, it was always fun to get stuff on the shelves at Toys R Us. After that, I moved into mobile and big data analytics, but I was able to leverage my knowledge of the video game business so that, you know, as the internet got everything connected and you could start tracking things and end up in this society that we have now, I learned how all of that stuff worked. I'm currently a product manager. I got out of Silicon Valley before they started really laying everybody off. And I work with biotech companies to analyze data and track process. Science has a whole lot of data that needs to be tracked and analyzed and presented. And this is because my wife is an MD pathologist. She supports cancer research and manages a lab currently at Bristol Myers Squibb. So, you know, the Silicon Valley stuff ended and she said, you know, we could use this stuff over here. So that was a lucky exit. But I'm still very interested in computing and entertainment, which is where I started all of this. And so how did I get into all of this? How did I find Parallax originally? Well, I was at the Maker Faire in San Mateo, 2007, 17 years ago. And this is like 2 miles from my house. I live in San Mateo. And my wife really likes Halloween. She's the kind of person who would make her own costumes when she was a kid and turn the garage into a haunted house, that kind of thing. And there was this one booth in particular that was there at that show, and with someone you might recognize. Oh, wait a minute. Are you guys hearing the sound? Because there's this is not as important as the later one. Does it come out of this? Okay, go ahead. No, of course not. Share computer sound. Ah, mono is fine. Let's try this again. Here we go. Click.
My name is John Williams. I'm the best electronics guy you ever saw.
This was one of the booths at the Maker Faire. What you see there is this is when he was running his company, Effects Tech. The bottom board there was the Prop 1, which uses a Parallax Basic Stamp 1. They rolled out boards with Parallax Basic Stamp 2 and the Propeller. So that started me on my microcontroller journey. And so since then, there have been a lot of Halloween projects. We went from just attending the Maker Faire to having an exhibit. This is a steampunk, mad scientist lab, a lot of stuff animated in there. When Stranger Things was new, I did a light up alphabet wall. If you saw that show, you remember the scene with the Christmas tree lights and everything. The Academy of Sciences in San Francisco liked it so much. This was just before the event started, they had me put this up in front of their T-Rex. That's always been a fun picture. It's a few years ago. And then as part of the Northern California Haunters group, we got a couple of Editor's Choice Awards one year from Make Magazine. That was fun. This is, however, something that you guys will like more. This is an actual demonstration of a prop, and this uses some Effects Tech boards to run it. This is the 1980s style computer console that is going to control the whole effect. You reach down, hit this big red button.
Alert. Experiment activated. Do not touch equipment.
Notice the EL wires over there. So that was hooked up to a whole bunch of other stuff that would trigger all these other props in the room. And there was a prop 1 and a prop 2 in that. The prop 1 did nothing but run the shift registers that managed all those LEDs. I hand soldered all of that together. Never again. That was a lot of work, but you don't have to do that kind of thing anymore. So let's go on to the actual topic. So this is where I come in from as sort of a super hobbyist. What is vibe coding? This is a new term. It was just introduced in February 2025. It describes where you take one of these LLMs and you describe your problem to it in as few sentences as possible as a prompt to give it, to tell it what you want it to do. And so you're not actually doing the coding, you're telling this as your assistant, here's what I want you to build. And this is done with any of these current LLMs, to varying degrees of success, depending on what you're working on. But it is definitely, my job, the engineers will take code and get advice on how to fix little web things and so on constantly. They just have they have an account with ChatGPT. You think of it as working with the LLM as your assistant. You direct it, it does the typing. And the reason this works is because they have scraped as much as they can off of the web. And but as you know, not everything on the web is dependable, and they attempt to predict what's happening next. And so because there's bad data and conflicting data, they will make incorrect connections. So you can get bad code out of this. Why did I pick Google Gemini to do this experiment? Because this all happened in the last couple of weeks. There's a YouTube blogger named Matthew Berman. I've been started following him. Initially, he wasn't very impressed with Google Gemini. Notice this is August 7th. But then Google put a lot of resources behind this. Here he is on March 25th, and saying this is amazing. What he did is he came up with the same test to throw at each of the LLMs. He said, put a Rubik's Cube on screen, rotate it around, let the user scramble it up, and then hit a button so you can unscramble it. And until Gemini 2.5 came out, none of them could do that properly. There was always colors mismatched or missing, or it didn't do things right, it looked ugly. And then suddenly he just gave it his prompt, which is about so long, and it came back with the right thing. I saw that and I was really impressed. I wasn't the only one. Here is the CEO of Google at their conference a week ago talking about this.
Take a look at this Rubik's Cube coded by developer Matt Burr. You might think it's a toy, but it's actually a really complex reasoning challenge. Adjustable dimensions, scrambling the squares, keyboard controls, and Gemini 2.5 Pro can simulate it all. It's a significant leap and shows the ability to produce robust interactive code.
So, and you see also, he was able to say, not just a 3x3 Rubik's Cube, but scale it up to whatever that is, a 7 or an 8 by Rubik's Cube. So that's, so that got my attention. And then, but my take on this is in experiencing vibe coding is that it's great for web and data projects because there's a lot of information out there. There's a lot of C, there's a lot of Python, there's a lot of JavaScript and all of those technologies. It's helpful for microcontroller projects because it needs a lot of examples, and it can't complete the loop on microcontrollers, right? You write the code, it goes off here, you have to sort of tell it what happened. It isn't, it's not quite the same. And the other thing is it works best if you don't care about what's under the hood. So when you take this big prompt, when Matt took this big prompt and stuck in it and it came back with this Rubik's Cube, he doesn't know what's going on. He just is looking at the end result. Now, on microcontrollers, if we're hooked up to physical things in the real world, we care a little more. So, and so my attempts to get code from these things have been frustrating for quite a while. I would get small things and I would break it up in little pieces and get help, but I could not get big results. But so what happened is I saw the announcement for this open house. I saw his reaction to Gemini. I thought, okay, let's see just how good this really is. And the key thing here is it spins in, we all know, spins in niche language. It's only supported on 2 microprocessors by 1 company. But the OBEX has been out for a while. So presumably spin would have been absorbed by all the LLMs. So if Gemini really took this big leap, let's see what happened here. So here's the project idea I had. And that's what I've got sitting right here is if you take a propeller and an ultrasonic sensor and some NeoPixels, and you hold your hand over the ultrasonic sensor and light up the RGB LEDs to indicate how far away you are. So I thought this would be a good educational project that you could use to address a lot of things. A lot of common questions. What's the sensor? How does it work? What are the RGB pixels? How are they different than regular LEDs? How would you control them? How would you convert the distance you measure into the LEDs? And this would be a really good little mini project that you could introduce to a lot of students. So let's take a look at the Gemini environment. Need to close this. Oh, come on, don't. Okay, come on. Did somebody? This is the important part. Come on. Okay, I am on the Wi-Fi. Yeah, I'm Parallax guest. Let's just click this again and restart it. There we go. All right, so this is Google AI Studio that I signed up for. I'm not paying for any of this, but what you see here on the right is the different versions of Gemini. If you look in the lower left corner of this panel here, you can see, let's unclick from that. You can see the knowledge cutoff thing down there in the lower left corner. It says January 2025. So this is all pretty current. One of the things you used to run into with like ChatGPT is they'd say this cuts off like a year and a half ago or something. So they're catching up and then taking this stuff and crunching it. There's a bunch of these other settings here that I haven't even worked with yet. So we're going to close that panel. This remembers all of this previous sessions. So I'm going to go into this one here and walk you through that. And there we go. So we want to get back to the beginning. And we want to reclose this panel. Come on. And we want to close that. So what you see here is these little bubbles. This is my prompt that I put in. This is the panel that's called the thoughts. We're going to look at one of these because you can see how it's reasoning through the problem. And then down here is the response. So what I decided to do from my previous experience is build this in pieces. So first, let's get this thing coding and spin just with the ultrasonic sensor. So that's what this prompt is. So you're telling it for parallax spin on the propeller 1, create code that reads an ultrasonic sensor and displays the distance on the PST and with the pins that I want. So that once it starts, you don't let it pick pins. You just tell it, here's what I want. And so let's open up the thoughts thing. This is where it starts getting interesting. You can see first it understands the goal. It basically repeats back to that, picks out what the components are. And this is where it starts getting interesting. It knows there's enough stuff about this ultrasonic sensor right there, so it just pulls all that data in. So what's interesting is that it doesn't rely on a library in this. It understands what the sensor is and then builds its own code and spin. And so you can see it explaining the sort of pulling the stuff out of wherever it's referenced, all the stuff about the speed of sound and calculations. Here's its stuff about how the propeller works. Here's the structure of spin, the different code blocks. Here's its implementation plan for spin. This goes on for a while. Here's the var block and the object blocks, the start method, and then the key thing here is this is its own method for measuring the distance where you could look at this and see where it's pinging the ultrasonic sensor and sending the trigger pulse and waiting for the echo, all of that stuff. It refines and reviews stuff, asks itself questions. I don't know how much of this is legit, but it's showing you that it's done this, and then combine all the stuff it's figured out together, and then it says, okay, here's your program. We're going to take a look at this in a moment in the PST so it comes out a little better. But the key thing here is that you take this, there's a button at the bottom here that you copy this, you paste it into your program, you try and compile it. It also has an explanation. This is sort of a shortened version of all those thoughts. And you can see here's what I'm doing. And but what you end up doing is you paste it in and try and compile it, and I got an error. This is the first thing that you do is you report the error like you're reporting it to an engineer. You say, this is the error, and on this line. And so exactly right here. And so it's got a little typo or misunderstanding that it needs to fix. It says, and this is your typical, you know, LLM. I'm sorry, sir. I will get right on that. You know, so. It says, you're right. Oh, this is not actually used anywhere. I'll get rid of that. We'll just comment that out. Here's a new version of the code, of that part of the code. And then I said, okay, you've got a similar error on this line. Oh, you're right again. My apologies. I got to fix that too. Okay, here's a revised version of that. And then there's one more thing. And these are all in the constant block. You did this, and oh, you've hit another rule. And you know, it takes this tone of, as if I had written the code. No, but whatever. And so I fixed that with this little thing here. And so here's the corrected block. And I say that compiled correctly. And so it says, okay, here, it's smart. And then it says, here's the complete corrected code that should compile successfully. So let's go over to here. That is this one right here. So here it's a little easier to read here, but you can see that it's absorbed the format of spin. So this looks really nice when you paste it in here. You know, all the comments, all of this stuff, you know, it's readable. It's not. And so what we've got is this is set up here. Load it up. Get the PST going. Should be COM10, right? Yeah. Oh, we're not on the right. I was testing something else last night. Hang on here. It needs to be at 11:52. Okay. There. There we go. And so you can come along and you can see. And so I'm going to hold this up, Andy. So if you've got, this is so people can see what it looks like on Zoom. Have you got it? Okay. Oh, okay. Okay. Well, actually, is it? Because I was going to flip back and forth between my screen and this thing, and now I've got Zoom as well. So I need, have you? Uh-huh. Oh, turn on the video. Ha. There we go. Now, this is for the people on Zoom. Nope. I don't know where I am on all this. Oh, there we are. Well, maybe you put pictures of this up later. I don't know. Oh, you got a point there. EOS? Is it easy? Is it this one? That's it. Oh yeah, geez, this went through so much stuff. So, oh no. Turn the blur off. Okay. Thank you guys. Is that in here? Video setting. Oh no, unblur my background. There. Perfect. Okay, so for those of you on Zoom, this is what I've got. Oh, I need to do that. So what you have here is the propeller. This is the old quick start board, breakout board. That's the ultrasonic sensor. And then this line of NeoPixels is for later. So this is just so that you can see when you were seeing the display on there, I was just moving my hand back and forth like this. So that's it for right now. We'll come back to that in a bit. And now I want to get back to sharing my screen. Andy, so do I have to do anything else? Yep. And say screen. Good. Okay, good. So there. So we'll get rid of PST there. Because go away. There. Huh. All right, we're back. Okay, so that was the first step. Is we went through, and that took 6 or 7 minutes, to get to that point. The hard part of this was that PST, the version that I've got there, you can't copy the error message out of it and paste it into something else. I had to manually type it. So there's, if you're doing any upgrades, it'd be nice to be able to do that because we come down here. This is the same stuff you just saw. So then the next step is, okay, now write code for the propeller that controls an 8-pixel string of NeoPixels. The data pin is P2. The NeoPixel should display a Cylon pattern. Since the first time had been pretty good, I just sort of said, let's see if it understands what a Cylon pattern is. I mean, it's common. It's been around for a long time, but this is where it gets more interesting because the first one, it fixed 3 little bugs and then it ran. This one decided it needed a library, and you can see that this code uses the common JM WS2812B spin driver object. You'll need to download this object file and place it in the same folder as your main spin file, or you can usually find it by searching online. This is a mistake they've made. What they should do is they should say, here is a link to the file that I'm using, because not just here, but in anything, it's like, how do you know you're going to find the right thing by searching for it? You don't know. And this means that there were several minutes of me running around and attempting to correct it. And then I finally found my way out of that. So the first thing that happened is I did all of this. I pasted their thing in, and I said, the correct name of the spin object is J, because I had an older one. And then it says, oh, you're absolutely correct. Thank you for the correction. The common driver is off. And it's like, okay, great. My apologies. And so then it fixes it and does some other stuff. And then I say, I was incorrect. After unzipping the archive, the correct name is this. However, there's an error. And we get back to one of these one of these typo errors, actually, this is more than just a typo. But we come along and it says, oh, you are hitting a common variation point in different versions or adaptions of these NeoPixel drivers. I should have picked up on this hint a little earlier than I did. But the specific version you have does not accept the 4th parameter. Okay, fine. It fixes it. I paste it in, and then I get another error. And stop execution of driver fails. This is where I start to figure out what's going on. Okay, that's an interesting error. Uh-oh. The stop instruction is definitely part of the spin language, However, it suggests the compiler isn't recognizing stop as a valid instruction. What? I have used this driver before and it works. What's going on? So we take this stuff, we paste it in, it fixes it, expects a subroutine name. I'm like, this is wrong. Okay, this indicates the specific version you are using does not have a public method. And then it finally occurred to me what to do. And that is, this is the version of the code that is currently on the Propeller OBEX. It is what I'm using. And so you also notice this is current, right? This is from 2024. So this goes on a long ways. Where's the MIT license? There we go. So it says, oh, and so the thought I had is, if you gave it the exact code, would it be able to analyze it and fix its stuff? And the answer is yes. You can see it says correction, correction, correction. There's 3 of these. That's a weird thing that they have here. There's 3 of these little corrections that it makes, and it uses the new driver. And then come on. There we go. And I say that works. So that is this one. Go away. Go away. Yeah, I've clicked on it. Here, we'll come down here. Do this. That's this one. And so, and you can see, there it is. So that, you know, to get that was probably the most frustrating part of it, was getting to that and getting that. And so so Andy, does this get seen if I do this? Okay. Oh, here, like that. Okay. Yeah, you want to stop? Go ahead, he's got it. There we go. Oh, actually, here, hang on. You can see it right here. So there it is. It sort of blasts out the camera, but it's there. Okay, so now we're going to go back to sharing again. And back here. So we're almost at the end of this. The first part is I got the ultrasonic, I got the NeoPixels, and then this is the big prompt. Now combine the 2 versions of the code, use the ultrasonic sensor to read the distance and light up the string of NeoPixels. The sensor should read a hand and light up the entire string. As you move your hand closer, the NeoPixels follow it and turn off from the farthest point. So the effect is that the line of lit NeoPixels gets shorter as you move your hand closer to the sensor. And it's like, that's a very specific description. And then it says, okay, here's what I'm going to do. Now, originally I started off with making it a meter. I eventually cut it down to 25 centimeters because it made more sense with the short thing, but that's an easy change. So then here's all the code. I slapped this in and I said, and that worked. And so once again, we can go over here. And was that it? Yep, there we are. So for the room first, yeah, you see that? And I'll have this over on the table. You can play with that. And now I'm going to stop the share and show this to people. There we go. So there's that. Now we go back to sharing. Okay, good. So 45 minutes to get to that. And it could have been shorter if I understood how to feed the errors back in, and if I was smart enough and understood to give it the right library and say, here's what I want you to use, instead of letting it fuss around and misdirect it. So that could have been 10 minutes to get to that. Seriously, it's kind of amazing. And again, if you look at the code, it's actually very well structured. So I showed this to my wife, and she says, "This is cool." Huh? You can't turn off that last LED. I would think that you would put your hand there and the last one would go off. And I go, okay, yeah, that's just one more condition. When you get within 2 centimeters, you should turn it off, right? Ha ha ha! Famous last words. Another 45 minutes. So I'm just going to give you an idea here. Is that you see where the scroll bar is? This is the first 45 minutes. Then this is the second one. And so what we're going to do is we're just going to hit a couple of little points in here, because what it eventually does is it gives me very detailed parallax serial terminal error messages that it wants me to feed back to it. So it turns out you also can't copy from the PST into anything else, which would have made this very easy. Instead, you've got to type up this long thing. So let's go down here. I'm just going to grab this and pull
Can
it
I make an
down.
interjection on that
Yeah.
one? Have you tried Control-Shift-C? I want to say that in Parallax Serial Terminal, Control-Shift-C will allow you to copy text for just for future reference.
I'll try it later.
Okay.
You know, so I'm just gonna. that's good to know. So I ran across a few of these typical little errors, but that's not what I'm talking about with the PST stuff here. So come on, catch up. Let's find one of those. Oh yeah, it worked. So here, so this is you can see how much stuff is going on here to try and figure out why it can't get that last condition in place. And first I'm fixing a lot of little bugs and this and that. And I mean this just goes on, and it actually becomes kind of tiring. Where's one of those long things? There we go. This is what I see, this bubble here. This is what I end up typing up and pasting back in. And so it's using this stuff to debug what its algorithm is to figure out. And so, you know, this is neat. I eventually had this in Notepad++, and then just kept updating it and copying from that and over into it. So, and then here was the thing that I eventually, the last little insight I got from this. See if I can find it. It's down here somewhere. Okay, there was another one of their little errors in an expression that it fixed. Text to fix those. Okay, you see this? Here where I say stop using # to mark comments, the correct character is single quote. So, you know, in Spin, when you mark a comment, it's with a single quote. In Python, it's with the # or the hashtag. So, you know, Spin's this combination of BASIC and Python. And it takes stuff from both. And so I'm thinking that it was solving some of these problems using its knowledge of Python. And so here and there, you would have like the code, and most of it would be commented out with a single quote, but here and there, there'd be one with the hashtag. And it's like, what are you doing? And I told it that, and it went, oh, you're absolutely correct. My apologies for repeating that again. And then once I told it that, it got it right, completely right. So there was something that I flipped in there. And so now for something that should be, oh, why do you, I moved this out of the way so that you wouldn't do that. There. So anyway, this is the last version. As you can see, now it will shut off the last one. Here, let me show you. So for the people watching at home, there we go. There, oh, let me tip that correctly. Yeah, that was another 45 minutes of stuff. So, so anyway, here, what I've come up with are, this better go away soon here. Tips for working with these LLMs. The thing is that you're guiding it through the process of helping you code. You do not want to try this thing where they call it one shot. With the guy with the Rubik's Cube, what made that so impressive is he took this big description. Here's what I want you to do. Gave it to the LLM, and it generated that Rubik's Cube thing in one command, which is impressive, but it's, you know, it's good if you don't care what's under the hood. You don't want to do that with a micro. I really don't think you do. You want to give it an instruction and test a result, so that you get this feedback loop going. You also should know your fundamentals. You want to be familiar with the parts of this. So I was familiar with ultrasonic sensors. I was familiar with NeoPixels. I thought of the project. I knew what it should be doing. You want to plan it in steps and build it in pieces. You want to feed clear information back so that it's very simple, direct feedback on this. And if you have a library, give it the code. It can take something large that you paste in and correctly analyze it. I haven't tried this with Claude or with ChatGPT, but I assume that they've seen that Google did this, and Google CEO stood up there and said, look at how impressive this is. So you got to figure that they're going to be on that if they haven't done it already. This should, oh my goodness, this should say wrapping up. But anyway, the one point about this is that emotionally, this is different than regular coding. In regular coding, you solve a problem and you're like, yes, oh, I got it. You're really proud of yourself. In this, when I got through the end of it, it was more like, finally, jeez. So, yeah, any questions? Yes. Thank you.
I'm wondering, you know, all the pieces, the propeller stuff, and all the drivers, where to get them. Would it save you time, even at this early stage, to do this with five coding, or would it have been quicker for you just to write?
Oh, I don't think I could have done this in 2 sessions of 45 minutes.
That's the total time in.
Yeah. The first one was 45 minutes, and then the second one, getting that last pixel, was 45 minutes. Yeah. And if I had understood these tips, which I just showed you guys, it would have been even faster. And if I knew how to copy out of the error messages, like if we go over to PST, if we go over to this here, oh, don't do this to me. What is all of that stuff? Okay, wow. Okay. So anyway, there's the error messages show up down here on the bottom and in this little pop-up dialog, and you can't copy out of that. That you need those error messages because you need the error message, and then you can of course highlight down here, and then in PST there may be a way to do that. So if you could do that and do that, then you get your feedback loop is very, very fast because you just go, oh, error, copy, paste, this line, copy, paste, go, and it takes another 20 seconds and comes back with a response. So that would have made it even faster instead of me sitting there typing, you know, for 30, 40 seconds a time. You know, I mean, I know that sounds like I'm complaining, but you know, I guess someone's kid is playing with this, huh? Yeah, the way I got around that teacher is to reboot too. Oh, is that what? Seriously? Yes. Okay, well, we'll let Andy deal with that as soon as I'm done here. Yeah. Yeah. I don't know. Yeah, oh, that was my experience with ChatGPT, is that you'd go into this project and it would like drop features halfway through, and you'd have to go back in and say, hey, you forgot to do this. And that was actually why I got frustrated with this quite a while back. And then when the announcement, when Matt Berman said, hey, this is really a game changer, I said, okay, let's go back and take a look at it. And then let's see if it can do spin, you know? And the answer is yes, it can, with a little bit of help. So yeah, there's so many parameters that you can play with, and I just sort of took all the defaults and just ran with that. Yeah. Did you have one? No. Okay. Any other questions? Yes. Have you tried learning? Sorry, what was that? Have you tried learning? No, I haven't done that. You're gonna see what would it be like with something that I've already done, and compare. No, I haven't done that yet. I hadn't thought of that. That's a good idea. You take something you've already done and then try starting from scratch with the LLM and see how fast it can do it, or if it can do it right. Okay. It's a good idea. I mean, this is all new to me and to other stuff. So it just, you know, it's also going to change really fast because of the millions and millions of dollars getting dumped into it. So yeah, we'll give it a shot. Yes. I didn't.
Does the AI tap into Johnny Mac's brain in real time?
Not yet. We need the neural link. you know, we need to talk to a certain disgraced person with Neuralink. Plug right on in. Well, actually, that's a good point, is that for this to get better, you want to put more examples of good code up on the web somewhere. So, you know, I was asked yesterday, well, what about Spin 2? Well, I don't know how many examples of that are out there for these things to learn from. And so the more, I think you want to have, just like you have any set of tutorials with a processor, here's how to read a button, here's how to light an LED, here's how to interact with this sensor or this playback thing. The more of those that I think are completely spelled out with proper Spin 2 code, then it'll just go suck all those up and be able to deal with it. So, yeah. Okay. Okay. Okay.